Hi there, Doug Stuman with IT Creations, and today I have the Gigabyte E152-ZE0 Edge Server. Edge servers are compact little units that are typically deployed in remote locations for use with the Internet of Things, used as a private cloud server, and other applications. At 400 millimeters or 15.75 inches in depth, it can be placed in a small enclosure or a network closet. Let's get to it. This platform, being as small as it is, makes for a short video too. We'll see. This platform is NVIDIA certified for use as a data center server, high-density VDI server, and as an edge system. That's kind of surprising. I mean, it only supports a single dual-slot GPU or two single-slot Gen 4 GPUs, and yet, NVIDIA is certified. It supports a single AMD EPYC 7002 or 7003 series processor. All the action is in the front of the system to save on space, since there may not be easy access to the back of the system. The front panel has access to the I/O panel, the two storage bays, two PCI slots, and a mezzanine card slot compatible with OCP 3.0 standards. On the right, two 2.5-inch hot swap drive bays for Gen 4 NVMe or SATA storage devices. That includes U.2 and U.3 NVMe drives. Then a pair of fans located behind that perforated panel. Lastly, the I/O panel. The I/O panel consists of dual USB 3.0 ports, a few LEDs and buttons, and then a dedicated server management LAN port next to two 1 gigabit Ethernet LAN ports for basic network communications. The PCI slots above and that OCP compatible mezzanine card slot is where you can kick it up a notch for faster network communications. Are you interested in a short-depth IoT edge high-density VDI server like this little Gigabyte E152-ZE0? If you are, then for a limited time you could save up to $500 off a system that's listed, or one that you can configure that's valued at $5,000 or more. Click that link for more information. When you're ready to make a purchase, just mention this video. Around the back of this server, there is only the single power supply unit, either an 800 watt 80+ titanium or platinum grade. Aside from that, just a few more fans for sucking that DRAM scented air out of the chassis. Once you remove the cover panel, you can see those three fans at the back of the chassis, right behind the CPU and memory module slots, with the PCI risers at the front of the platform. Those risers at the front are low-profile PCI 4.0 by 16 slots and can be used for network cards, hard drive controllers, or HBAs with easy access from the front of the chassis. To the side, another two slots, specifically full-height, full-length PCI 4.0 by 16 expansion slots for GPUs. That dedicated 1 gigabit Ethernet port can be used to access the system remotely by using the integrated ASPEED AST2600 baseboard management controller. Gigabyte provides two options to manage the system: the Gigabyte Management Console, which comes pre-installed. It offers real-time health monitoring and management through a standard browser interface. Available for download is the Gigabyte Server Management, or GSM. GSM leverages the Gigabyte Management Console and is also compatible with IPMI and Redfish protocols. With GSM, you get more granular data and can manage your entire infrastructure, whereas the Management Console is really for a single server or a small cluster. Those full-height, full-length slots can be outfitted with a single double-slot GPU or two single-slot GPUs. GPUs listed in the specs include the NVIDIA A100, A16, and A2, all Ampere architecture-based GPUs. Now, I did discuss the NVIDIA A16 GPU just a few videos ago, and you can see that breakdown at about the 722 mark on that video link for the G292-Z44 GPU server in the upper right. For this video, we'll take a look at that NVIDIA A100 40 gigabyte unit with tensor cores. As the A100 and the A16 have the same power draw at up to 250 watts, I'm going to assume that is the top wattage supported on the system. That other card, the A2, which is also the smallest of the three cards, has a single slot width and a power draw of only 60 watts. With only 60 watts, the A2 does not require additional power connectors and receives its power directly from the PCI slot. For high-performance computing, AI, data analytics applications, the A100 40 gigabyte GPU is the choice. For virtual desktop infrastructure, or VDI, the NVIDIA A16 GPU would be a great choice as well. Next, for graphics, the NVIDIA A2 is a professional graphics card, and you can install two of those. I will mention that none of these GPUs have any DisplayPort connectivity and are not designed to have monitors directly attached. Now, that NVIDIA A100 is also a great card for graphics, but also for AI, data analytics, and high-performance computing applications. It offers 40 gigabytes of HBM2E memory, and yes, there is an 80 gigabyte version, but that one was not listed, and it also has a power draw of 300 watts, which has a TDP that's 50 watts more than the 40 gigabyte card. The NVIDIA A140GB has a PCI 4.0 by 16 interface with a base clock of 765 MHz and a boost clock of 1410 MHz. Memory bandwidth is listed at 1.56 terabytes per second with a 5120-bit memory bus. This card does not support DirectX 12 or DirectX anything, so no good on gaming, allegedly. I will mention the other two cards do support DirectX 12. Here are a few other stats. You can also install some additional storage in the form of an M.2 PCI card with 4 M.2 slots. That would require a by 16 slot, and we have 4, although 2 of them are low profile. I'll also mention that if you do install a double-wide GPU, then one of the full-height, full-length slots will be unavailable. There are also 2 PCI 4.0 by 4 slots on the system board specifically for M.2 drives. This system is outfitted with a single AMD EPYC 7002 or 7003 series CPU with a configurable thermal design power rating of up to 280 watts. Both series top out at 280 watts, and that would include CPUs with up to 64 physical cores and 128 virtual threads. Although with the 7003 series CPUs, you do have a choice of the standard offering Milan X with a larger L3 cache for technical workloads, and then some high-frequency models with an F in the model name. Those with the F may have half the cores of standard CPUs, but are performance optimized with higher base and boost clock frequencies. Also CPUs with a P suffix that indicates they are designed for single-socket platforms. With 8-channel memory architecture from the CPU and 8 DDR4 memory module slots on the system board, memory speed is optimized at 1 DIMM per channel. No worries on the memory speed supported by either the 7002 or 7003 series CPUs, as the entire product family will support memory speeds with 1 DIMM per channel of up to 3200 megatransfers per second. That is assuming you purchased memory that is capable of speeds of up to 3200 megatransfers per second. If not, that will bring the speed down, as the platform will default to the slowest performer between the memory and CPU. I do hope you enjoyed this somewhat short server review of a short depth server. The Gigabyte E152-ZE0 server is designed to support applications at the edge for processing on-site rather than taking the long way around through a data center or the cloud. Also for remote offices and small to medium-sized businesses. If you have any questions on this platform or any others, leave a message in the comment section below. If you are interested in this system or perhaps another Gigabyte system, then check out IT Creations. I placed several links in the description below this video, or you can use that link right there. itcreations.com. Until next time, I'm Doug Stuman, and thanks for watching.